Today we are going to learn about mastering virtual environments with venv in Python. We will explore how to create and manage isolated Python environments, equipping you with the skills to efficiently handle project dependencies and avoid conflicts.
Python virtual environments are tools that help manage project-specific dependencies by isolating them from the global Python environment. This isolation is crucial, especially when working on multiple projects that might require different versions of the same package. By using virtual environments, you can ensure that each project has its dependencies managed independently, reducing the risk of version conflicts. The venv module is a built-in Python tool that allows you to create lightweight virtual environments without needing additional installations. Throughout this video, we'll explore how virtual environments work, their importance, and how venv can simplify dependency management. Using venv to create virtual environments offers numerous advantages. First and foremost, it allows for project-specific dependency management, meaning that each of your projects can maintain its own dependencies without interference from others. This is particularly beneficial when different projects require different versions of the same package. By isolating project environments, you avoid conflicts that arise from global installations. Furthermore, venv simplifies collaboration on shared projects. Team members can share their project's environment configuration, ensuring that everyone is working with the same setup. This also aids in reproducibility, allowing you to recreate the exact environment on any machine. Moreover, virtual environments facilitate testing and development by providing a contained space to experiment without affecting other projects or the system's global environment. Creating a virtual environment with venv is a straightforward process. First, navigate to your project's directory using the command line. Once inside the desired directory, you can create a virtual environment by executing the command python venv_name, where env_name is the name you want to give your environment. This command sets up a new directory with the necessary files to run a separate Python environment. After creating the environment, you'll notice a new folder with the same name as your environment. This folder contains a bin directory with the Python executable and scripts to manage the environment. To start using the virtual environment, you'll need to activate it. On Windows, use the command source env_name/script/activate, and on Unix or Mac OS, use source env_name/bin/activate. Once activated, your command line prompt will change, indicating that you're operating within the virtual environment. This isolation ensures that any packages you install or scripts you run are contained within the virtual environment, separate from the global Python installation.
Activating a virtual environment is crucial for ensuring that the Python interpreter and packages used are those within the environment, not the global ones. When you activate a virtual environment, it modifies your shell's environment variables, directing Python commands to the virtual environment. On Windows, you activate by using source env_name/script/activate, while on Unix or Mac OS, the command is source env_name/bin/activate. Once activated, the command prompt will change, often prefixed with the environment's name, indicating that you are working within the virtual environment. To deactivate, simply type deactivate in the command line. This command restores your shell's environment variables to their original state, effectively switching back to the global Python environment. Switching between environments is as simple as deactivating the current environment and activating another. This flexibility allows you to manage multiple projects seamlessly, using the specific configurations and dependencies required for each one.
Once your virtual environment is activated, you can use pip, Python's package installer, to manage packages within that environment. Installing packages in a virtual environment ensures that they do not interfere with the global Python installation or other projects. For example, to install the requests library, you would use the command pip install requests. This command installs the package within the active virtual environment. One of the key benefits of this approach is the ability to manage specific versions of packages, which is crucial for maintaining compatibility and avoiding conflicts. If you need to remove a package, you can do so with pip uninstall package_name. To verify the packages installed in your virtual environment, you can run pip list, which will display all the packages and their respective versions. This granular control over package management helps maintain a clean and efficient development environment, tailored specifically to the needs of your project. The requirements.txt file is a simple yet powerful tool for managing dependencies in a Python project. It serves as a list of all the packages your project depends on and is essential for sharing your environment with collaborators or deploying your project on different systems. To create a requirements.txt file, first ensure your virtual environment is activated, then run pip freeze >requirements.txt. This command captures a snapshot of all installed packages and their versions, writing them to a text file. Sharing this file allows others to recreate the exact environment by running pip install or requirements.txt within their virtual environment. This process installs all listed packages, ensuring consistency across different setups. Regularly updating your requirements.txt file is a good practice, especially after adding new packages or upgrading existing ones. This approach not only aids in collaboration but also ensures that your project remains reproducible and maintainable over time.
When working on collaborative projects, using venv can greatly enhance consistency and efficiency. One of the best practices is to ensure that all team members set up their environments using the same requirements.txt file, which guarantees that everyone is working with the same package versions. Documenting dependencies and any specific setup instructions in a README file can also aid new team members in getting up to speed quickly. Integrating your virtual environment setup with a version control system like Git is another effective strategy. By committing your requirements.txt file in any environment-specific scripts, you ensure that the environment configuration is versioned alongside your project code. Regularly updating the environment and dependencies is crucial to avoid security vulnerabilities and ensure compatibility with new package versions. Effective communication among team members about any changes to dependencies or setup procedures can help prevent misunderstandings and ensure smooth collaboration. While working with venv, you may encounter some common issues, but most can be resolved with a few troubleshooting steps. One typical problem is failing to activate the virtual environment. Ensure that you are using the correct command for your operating system and that you are in the correct directory. Another issue might be package installation errors, often caused by incorrect package names or network issues. Double-check the package name and your internet connection. Version conflicts can occur when different projects require incompatible versions of a package. To resolve this, ensure your requirements.txt file accurately reflects the dependencies needed for each project. If your environment becomes corrupted or outdated, consider recreating it by deleting the existing environment directory and creating a new one. Lastly, when updating Python versions on your system, you might need to recreate your virtual environments to ensure compatibility with the new Python version. Staying aware of these potential issues and their solutions will help maintain smooth development workflows.
In conclusion, mastering virtual environments with venv is a crucial skill for any Python developer. We've explored the benefits of using venv for project isolation, creating and managing virtual environments, and the importance of maintaining consistent project dependencies. By isolating your project's environment, you ensure that your development process is both efficient and conflict-free. We encourage you to apply what you've learned by setting up your virtual environments and experimenting with package installations and requirements.txt management. Remember, hands-on practice is key to mastering these concepts. For further learning, consider exploring Python's official documentation on venv and other community resources to deepen your understanding.